spark ignition four-stroke engine, also known as a four-stroke piston engine, is mostly used in small aircraft. The engine converts chemical energy, such as fuel, into mechanical energy that takes place within the cylinder of the engine. There is a repetitive up and down or back and forth linear motion of the piston that produces mechanical energy to rotate the propeller.
In a spark ignition four-stroke engine, there is a four-stroke operation cycle. These four separate strokes are the process of intake, compression, power and exhaust. The intake stroke begins as the piston is pulled down and at the moment the intake valve opens, drawing the fuel-air mixture into the cylinder. The compression stroke follows when the intake valve closes and moves back to the top of the cylinder. The power stroke begins when the fuel-air mixture is ignited. Due to the great pressure increase in the cylinder, it forces the piston downward, rotating the crankshaft. The final process, the exhaust stroke, is used to force the burning gases out of the cylinder. It happens when the exhaust valve opens and the piston is pushed up towards the cylinder head again.
Even though most of the intense heat produced by the burning fuel is expelled through the exhaust system to prevent the engine from overheating, the remaining heat must be removed or dissipated. The oil system cools the interior of the engine, but there are numerous ways to cool the exterior of the engine: enrich the fuel-air mixture, reduce power, or even increase the airspeed. Most small aircraft are air-cooled, which is accomplished by cool air flowing into the engine compartment through an inlet behind the propeller hub. This cool air is directed by baffles to the hottest part of the engine, such as the cylinder. The air is then expelled through the opening or openings in the lower aft area of the engine cavity. However, this system is less effective during high power, low airspeed operations such as taxiing, takeoffs and go-arounds. Also, high speed descents can shock cool the engine due to the excess air.
In a spark ignition engine, the ignition system provides a spark that ignites the fuel-air mixture in the cylinders. A high-voltage electrical current is generated by a magneto to jump a spark across the spark plug gap in each cylinder. When the starter is engaged, the system begins to fire and the crankshaft begins to rotate. As the crankshaft rotates, it continues to operate. Some aircraft have the advantage of two individually installed magnetos, which improves combustion of the fuel-air mixture. Also, if one magneto fails, the other is unaffected. To identify a malfunctioning ignition system at pre-takeoff check, turn the ignition switch from both to right and then both to left. A small decrease in engine RPM is normal during the check. If the engine stops running or if the RPM drops significantly when performing pre-takeoff check, the aircraft should not be flown. When shutting down the engine, turn the ignition switch to the off position to avoid the engine from firing and turning over and any other hazards from occurring. A carburetor is a device that mixes air and fuel for the engine in the proper ratio for its combustion. Adjusting the mixture is essential during flight. As the aircraft increases its altitude, the density of the air entering the carburetor decreases. The fuel is being mixed with less air now because the air is thinner. To allow maximum air into the engine, you must keep the fuel-air mixture rich. If the mixture becomes too rich, an appreciable loss of power and engine roughness causes the spark plug to fail due to the excessive carbon buildup on the plugs. This may happen before takeoff at high elevation airports and during climbs or cruise flights at high altitudes. The mixture may also become too lean, descending from a high altitude due to excess of air. This causes detonation in the engine, resulting in rough engine operation, overheating, or a loss of power. The mixture must be leaned using mixer control. By monitoring the engine temperature and enriching the mixture can maintain the proper fuel-air mixture.